Hello everyone. So today I'm going to continue with my six companies 30 days challenge. So today I'm going to solve this second question of Microsoft series, which is combination sum width at best. So let us read the problem. It states that find all valid combinations of k numbers that sum up to n such that the following conditions are true. We can only use 1 to 9 digits. I mean, in a combination, we can only use 1 to 9, and we can use one digit at most once. So, these are the two conditions which need to be satisfied, and so we need to return all possible valid combinations, and there should not be any duplicates. So, yeah. So here k denotes the size of that combination, like how many digits are to be there in that combination, and n is the total sum of that combination to be. So, and we can use only 1 to 9 digits, and each digit should be only be used only once, and there should not be any duplicates. So how are we gonna do that? Okay, so as you can see, we can either in 1 to 9 digits, either we can take one digit or we can skip that digit. So here we can see a chance of taking and not taking. So here we can use backtracking approach. Usually in backtracking approach, we deal with the situations of true or false, or taking that way or not. So this question is of the similar type. So let us take a vector of vector outside here, outside of my driving function. So here I'm going to make a backtracking function. Let it be helper, and in that I'm going to pass my like the current sum, and we are going to need the digit which we have to add into digit, and we'll be needing a vector to store that combination. And what else? I think this is enough for because and yeah, we also need the size to be the combination size. So yeah, so whenever we write any recursion function, we have to take care of the breaking condition. So here, if the vector size is equal to k, so in that case we just have to check if the current sum is equal to n. We'll take a global variable here, n. So if it is equal, then we'll be inserting instead of vector, we better take a set of vectors, because we need to have unique combinations. So we'll be using a set here. Answer dot insert r temp, and we'll be returning here because break condition is there. So initially our current sum will be 0, so we'll be adding our current sum with the digit. I'm sorry, with the digit, yeah. So after that we'll be calling our recursion function here, where we increment the digit by 1. As you can see, yeah, okay. So actually, yeah, decrement, I mean, I'll be using digit as 9 initially, so I'll be decrementing it. And temp, as usually, yeah, I have to update my temp as well, so I'll be putting my element, I mean the digit which I am adding to my current sum. So I'll be passing that and k normal. So after that, here I'll be adding the backtracking step, where I'll be removing my element, the current element, right, and decrementing my sum as well, right, and again calling the helper function with the updated current sum. And if I'm sorry, if the digit is less than 1, we should return, because there are no numbers. So I guess this should work. So for initially we need to check this, and we need to declare a vector as a temporary vector for storing, and after that we'll be calling our helper function here with current sum as 0, and digit will be starting with 9, and vector will be passing a temporary vector here, and k as given here, k. Okay, we don't need reference here, I guess. I think, okay, fine. We'll be adding, for our result, we'll be declaring an vector of vectors, and for auto combination in the set, we'll be adding the valid combinations in our result. So yeah, and we'll be returning our result. Okay, let's see if this works. Okay, I don't know, I'll just make these mistakes every time. Pop back, temp dot pop back. Isn't that the function which we have? Okay. Okay, we'll be searching vector pop back. So yeah, value to be added in the back. For pop back. Oh, okay, I'm sorry. So there is no need of passing the value here. Okay, I'm sorry. So that was push back. So here we don't need this. Now I think the syntax is okay. Okay, let us check. I mean, I have done this before, and yeah, it works. So this was simple backtracking approach in which we have used a temporary array to store every combination, and we have also used a set for unique combinations. So I hope this video gets you more clearer idea on the problem, and I have also been updating my solutions in the GitHub repo. So you can also refer to this. So I'll be making videos on this and this also. So you can check this link on description. So thank you.